Hey everyone, I'm Robbie. I'm a software engineer at Gridspace. We're here today at Leland Stanford Junior College. It's not a real university, apparently. We are going through defining hot terms that you might hear in the field of AI and machine learning. Today will be what's called the training split, or otherwise known as the train test split. Anthony, when you were in school, you had homework, you had lessons. Did you ever have a test where the test was just copy-pasted questions straight from the homework or straight from the textbook?
Yes, sometimes they do that, and sometimes it would be like new questions.
Yeah, and what do you think was a better way for the teacher to evaluate whether you had actually learned something from their teaching and your homework?
Well, sometimes when they would reuse the questions from the homework, I just had it still memorized.
Exactly. So that's probably a poor practice as a teacher if you were to just pick the same exact wording, if you're a math teacher, the same exact numbers for the questions, because there's always a chance that the students have just memorized in their brain the exact same numbers, the exact same words. If it's multiple choice, what choice in which one of A, B, C, or D is the right choice, rather than actually internalizing, gaining intuition, learning problem-solving skills for that domain. And so when it comes to the train test split, that is a similar practice that we want when it comes to evaluating our machine learning models. If you were to have this big, great set of training data, you have your statistical model learn from that data, but then the way that you evaluate is you just feed it back examples that it already saw from its training split. You would get a vastly overestimated value of what that model has actually learned. What you would want is to have some sort of split, some sort of difference between what the model sees or what the model trains on and then what it actually is evaluated on. And so that's important for things like research papers or very publicized data sets on the internet. There's going to be a set of training data that should be isolated from when the model is actually evaluated. And you're going to want that when it comes to real-world systems. When you're deploying your model is going to see things that it probably didn't see exactly when it came to its training process. But if you have done a good job with other tools such as regularization, which is in a different video, then you have a better opportunity of the model taking what it learned from the training data and not just memorizing, but actually taking generalized learnings into the real world. But if you're evaluating on the same data that was trained on before deploying, you're probably going to be sadly misinformed as to the potential of your model and be pretty disappointed when it goes out into the real world. Train test split, something that you probably want to practice in your own machine learning life.
Robbie's the TA of our YouTube channel.
If you're on the internet or you're on Reddit and you hear some of these terms, you're reading through MSNBC and there's these things about OpenAI or DeepSeek and you want to learn more about those terms, feel free to put them in the comments. We've got a bunch of other smart people here at Gridspace that know way more about these things than I do, and they'll be happy to explain them to you like I did today. Thank you.